So in this video, I'm going to try and explain the inverse of trigonometric functions a little bit. So we'll start out with a problem, a pretty basic problem, something that looks kind of algebraic in a way. So it says solve the equation 2 cosine theta plus 1 equals 0, where I've restricted theta, which is an angle, between 0 and 360 degrees. So we'll keep it in degrees so we can, degrees are the first thing instead of using radians. Degrees are a little easier for us to think about if that's what we've learned since elementary school. So, so what does that mean? And we could guess and check and start plugging angles in to theta here until we just got 0. But let's try and solve this thing, and just like we would any other problem. So if you have 2 times cosine theta plus 1 equals 0, we're going to solve this just like an algebraic problem. So we're going to isolate theta. We need to get theta by itself. So the first step, just like anything, is we're going to undo this equation. So we're going to subtract 1 to get the 1 out of the way. And so when you subtract 1 from both sides, you're left with 2 cosine theta equals -1. Okay. Then we've got 2 times cosine. So if you have had algebra 1 and are pretty good at algebra 1, but no trig, at least you could get to this part. So you would divide both sides by 2. And so now we've got cosine theta equals -1/2. Well, that throws us into a predicament because we don't know how to get theta by itself if you don't know how to do this. Is there a way to undo cosine? Well, if you think about what this means we want the angle whose cosine is -1/2. Okay? So there is, in mathematics, in trigonometry, we can do what's called an arc cosine. And so we can undo this, and so it would look like this, arc cosine, or these are the same thing, cosine to the -1. Both of those are inverses of the cosine operation. So this could be rewritten as theta equals arc cosine of -1/2. Or theta equals, and this is the same thing, same thing, is cosine, the inverse cosine of -1/2. So in both cases, this theta, we want the angle whose cosine is -1/2. So this is the inverse operation of that. Well, and I picked 1/2 for a reason. We've got a couple triangles that are really nice to work with. One's the 30, 60, 90. That looks like 60, that looks like 30, and it always has the operation that this, if this is 1, this is 2, and this would be the square root of 3. So in that triangle, where is cosine 1/2 at? Well, it'd be if you went from this angle, because this would be adjacent, and this would be the hypotenuse. So, and this would be opposite. And so back to our, if you just look at our basic SOHCAHTOA stuff, sines opposite over hypotenuse, cosines adjacent over hypotenuse, and tangents opposite over adjacent. So what we're looking at here then is, let me just go back up, is we're looking at 60 degrees would give me a cosine of 1/2. But that doesn't help us with the negative part of it. Well, that's when we get into the 360 degrees, a full circle. So if you think about this on a full circle, here's 0, here's 90, 180, 270, and then back to 360. Where would cosine be negative in this quadrant? In quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Well, remember all of our, if we just drew in all of our terminals for each quadrant, cosine, if theta was here, cosine would be x over r in this case. Well, x is positive because it goes to the right, and r is positive because that's the radius of a circle, so cosine would be positive there. If we look at the second quadrant, I'll do it in green. The second quadrant would look like this, where my reference angle would be here, and here we'd have a negative x value and a positive y value, and radius would be positive. So there's one place where it could be negative, because you have a negative adjacent over r would be negative. So we know it's in the second quadrant. And then if you check the third quadrant, I'll stick that back in there. If you check the third quadrant and stick that in here, and you do the same thing again, we'd have that negative x and a negative y and an r value. And so again, our adjacent over adjacent over hypotenuse is again negative. So cosine's negative in the second and third quadrant. So I'm just going to get rid of that and start over. So knowing that, we have one angle that's 60 degrees in this quadrant. That's the reference angle, 60 degrees in the second quadrant, which would mean that has to be 120 degrees to make the full 180. So we know one of our answers is 120 degrees. Then the third quadrant answer, we'll do that in green here. Again, that'd be 60 degrees here. So we'd come around, there's 180 plus another 60, so that would be 240 degrees. So that's our other angle. Whoop, not 248, excuse me. 240 degrees. So if you plugged in 240 degrees and 120 degrees in that original problem, you would have, it would come up with 0. So if you took, and make sure your calculator's in degrees, but if you did 2 times cosine of 120 plus 1, that will be 0. And 2 times cosine of 240 plus 1 would also be 0. So that's kind of a quick, trying to explain all parts of it. But let's look at another example. So, of course, let me pause for a second. So, for instance, we have sine x equals square root 3 over 2. This can be rewritten as the x as the arcsine of square root 3 over 2. And so it's nice to think of it like this. X, in our case, since that's our angle, so x is an angle whose sine is square root 3 over 2. So we'd want to know where all angles give you a sine ratio of square root 3 over 2. And so if you wanted to figure out what angles those are, again, I picked the 30, 60, 90 situation. I'll just draw that again quickly. So there's 60, there's 30, there's 90. This is 1, this is 2, this is root 3 in that particular triangle. And so where is sine square root 3 over 2? Well, it's 60 again, because here's opposite of 60, and then here's hypotenuse, which is the definition of sine, opposite over hypotenuse. So in our case, x would be 60 degrees. And if we defined it between 0 and 360, and it was a positive root 3 over 2, sine is positive in the first and the second quadrant. And so 60 would be one of our answers, and 120 would be the other one. So those are our two answers between 0 and 360. And then if you wanted to go beyond 360 degrees, it would be all angles coterminal with 60 and 120. Excuse me. So just to wrap this up, let's say I had something like this. Let's say I had cosine of the inverse sine of 1/2, for instance. Well, this part in the middle, right here, inside there, that's the angle where sine is 1/2. So we could draw that situation. Okay, if this was my angle, we'll call it theta. Sine of 1/2 of that would be 1 there and 2 there. And then it wants you to find cosine. Well, if you did cosine, so now this is theta right here, that inverse sine of 1/2. I happen to know that's 30 degrees, but if you didn't know that, so we could find cosine of 30. But if you didn't know that, you could just complete your triangle with Pythagorean theorem. And we just need this value here. So x squared plus 1 squared has to equal 2 squared. Well, x squared plus 1 equals 4. So x squared equals 3. So x is equal to the square root of 3. So now it's possible to find cosine. So well, cosine of theta would be square root 3 over 2. And again, that's what this would be. Okay, so hopefully that helps you. Hopefully I didn't confuse you more than I helped you. But best of luck with this, and I'll see you next time.